Hello friends, let us look at the important point in curve tracing, and that is the symmetry about the axis. So here I have written some of the rules. If your equation, when your equation is symmetric about x-axis, how will find out this? See, whenever you replace y, only y by minus y, okay, in the given equation, and there is no change in the equation, then certainly the curve is symmetric about x-axis. I'll give you one example of this. The example is like this. You take y square equal to 4x. Okay. If I replace y by minus y, the equation remains unchanged because y square of minus y square is same. Okay. And what this curve is, it's a parabola which is symmetric about x-axis. See that it is symmetric about x-axis. Okay. Fine. Symmetric about y-axis, you replace x by minus x and there is no change in the equation. The example is, again we'll take one parabola, x square is equal to 4y. Right? How this parabola looks like? This looks like symmetric about y-axis. Okay. Then symmetric about both axes, you replace simultaneously x by minus x and y by minus y. There is no change in the given equation of the curve. Okay, then the curve is symmetric about both axes simultaneously, and the equation is, of course, you can take circle, symmetric about both axes simultaneously. See that this part is symmetric over here, this part is symmetric over here, right? So x replaced by minus x, no change, y replaced by minus y, no change simultaneously, right? Here only x replaced by minus x, no change. Here only y replaced by minus y, no change. Okay, so remember these three rules. We'll see three more rules now. Okay. Let us see the rest of the three rules. Symmetric about origin. That means the curve exists in opposite quadrants. Okay, maybe in first and fourth, third, or second and fourth. Okay. See, the rule is same as it is about both axes. If x is replaced by minus x and y is replaced by minus y, there is no change in the equation. But remember, here there is a difference in the this rule and the previous one, that is symmetric about both axes. And the difference is that here the degree of x and y is odd. Okay, whenever the curve is symmetric about both axes, the degree of x and y has to be even. Okay, so please note this. Here x and y's degrees odd, but still if you replace x by minus x and y by minus y, there is no change in the equation. Okay, I'll give you example of this, and the example of this is say x equal to y cube. If I replace x by minus x, I'll get minus x over here. If I replace y by minus y, I'll get minus y cube, and both these get changed and we'll get the same equation once again, right? Okay, and what is this curve looks like? This curve is like this. This is the curve. So see that it is symmetric about the origin. Okay, right. Symmetric about y equal to x line. That means, see, this is y equal to x line. So is the curve symmetric about this line? How you determine? You can determine that if you replace x by y term and y by x in the given equation, and there is no change in the equation, certainly the equation has to be symmetric about y equal to x line. One equation is xy equal to c. Okay, it's a rectangular parabola, right? So it is like this, rectangular hyperbola. Okay, symmetric about line y equal to minus x. So that is this is y equal to minus x line. Okay, whether the curve is symmetric about this line. Okay, and that can be obtained by replacing x by minus y and y by minus x simultaneously. There is no change in the equation. You can take the example as xy equal to minus c. Okay, right? So this is this hyperbola. So it is symmetric about the line y equal to minus x. This is symmetric about the line y equal to x. Okay, and this is symmetric in the opposite quadrant. Note here the degree of x and y, they are odd. Okay, the previous example that we have looked for, that is symmetric about both axes simultaneously, we have written the same rule, but there the degree of x and y is even. Okay, please note this point, right? So note all these rules. We'll see the illustration of the symmetry in the next video. Okay, thank you.